The last example we did with trig polynomial is super important. So I'll give you the general formula. This is really famous and it's used in differential equation and engineering and physics all the time. So if I have a function f, sorry, f is missing from my statement. If I have a function f and I want to approximate it on the space of trigonometric polynomial of degree n or less, I'm going to get something like this. And we can get pretty nice formulas for this. So a0, we know it's the integral of 1 over the inner product of this with f times, well, here we don't have a 1 over root 2 pi, so let's put that there. It means it's 1 over 2 pi, the integral from 0 to 2 pi of f of x dx. Alright, a1 is the integral of cos of x and f of x, but I need to divide. If you want, you can see it that way. That's actually quite nice. Let me do it like that here as well. I need to divide by the length of 1 here. I need to divide by the length of cosine here, squared, and so that's going to be 1 over pi that I divide by. So f of x, cos of x. And I could generalize this with a k, so cos kx here. Same thing here, cos kx. And same thing here, cos kx. Alright, so this is the integral that gives me the kth coefficient, and if I want the kth coefficient, then I'm going to use sine kx, f of x. What's interesting is this is one specific example of taking a projection, and it gives us something super important called the Fourier coefficient. So these numbers A0, A1, AN, B0, sorry, not B0, B1, Bn are called the Fourier coefficients of the function f. Right, this is super important for periodic function. It's very important for recordings. How do you? I'll find it. All right, so these are called Fourier coefficients, and the Fourier series well, instead of stopping at a polynomial, we'll keep going forever. So it's the sum from, do I want to use n or k? K equals 1 to positive infinity of bk cos kx plus, sorry, this one's the a, this one's the